All right, I hope everyone is doing well today. In this video, I'm going to cover Chapter 6 for Intro to Statistical Analysis at Southern New Hampshire. And this is for weeks 5 homework. So again, complete your 5.1 Smart Book reading assignment first, and then continue on into the 5.3 homework. Again, this is the time I'm making this video, so your dates on your class may be different, but the problems are similar. So let's get started. All right, continue. All right, so the first question, which of the following cannot be probability distribution? So remember, for something to be a probability distribution, it has to have an event, which is what x's are. So we have 0 and 1 here, and we have x's here, and we have x's here, and their numbers, so that is good. Then they also the probabilities have to add up to 1. So 0.3 and 0.8, 30 and 80 are way over 100%, so A's out. 50 and 60 is over 100%. That one is also out. 40 plus 20 is 60, 70, 80, 90, 100. So, could not be. So make sure you read that. So B is, which means A and C are not. Again, we can do the check to work. And check to work is good, and you can just literally sit here and check to work till you find the right answer. I don't recommend doing that because when you go to take your final, you can't. So it's better to let it check your work. That way you know before you finish. However, make sure you understand why it's correct, because when you go to take the final, if you are just using check my work just so you can get the credit on the homework, it's not going to help you take the final, right? So it is a useful tool, but don't take advantage of it because it just will not be good in the end. All right, so here is our probability distribution, right? And again, it shows that it sums to 100. X values are all numbers, and they all have a probability, so it is a valid probability distribution function. So to read your chart, E equals is the numbers in the chart, right? And so I'm going to bring up some Excel here. This one, you notice it doesn't let you download it into Excel, but I'm going to create the table just because it's quick and easier to show the calculations. You do not have to do this. You can just use your calculator, but you should know by now that I like Excel. And so I'm just going to type these in real quick. And it takes a minute, but it will speed up the rest of the problem. And it'll really make it faster when we do the other ones, right? And so again, if you wanted to check these, even though they sum it, you can highlight them, go one past, click on the sum, which you can't see, so I'll make it big so you can see it. Here's your auto sum. And you can see that it did just say it adds up to 1. So the problem's being honest, which is a good thing as well. And now what we can do is answer the question. So when it's equal, it's just the number in the chart. So probably x equals 100 is 19. So let's make this a little bit smaller so you can see both. All right, so now we can see both. So that is just going to be 0.19. So this one is x is less than or equal to 75. So you want to add up the numbers 75 and less. So I can highlight those. And you can see here at the bottom, it says the sum. So that's 0.81. You could also take the complement when you do 1 minus 0.19. So that's 0.81. Greater than 50, it doesn't have the equal sign. So that means it does not include 50. So I just add the 27 and 19, which gives me 0.46. And then anything less than 100 is the numbers less than 100, which is the same as saying less than or equal to 75. So that's the same answer as we got before. Which of the following expressions in part A and D is a value in the CDF? So what a CDF means is you take the first value and that's what you start at, right? So I'm gonna put this in my Excel, CDF. Sorry, I had to sneeze. And now what you do is you take the previous value and you add it to the current PDF value. So CDF, cumulative distribution function, just means to add. So again, take the previous CDF value, add it to the current PDF value, and then do it one more time. And if you do everything correctly, your CDF will also end in 1. So the only number that's the same in both the PDF and the CDF is the starting value. So that would be the answer in part A. Interestingly enough, though, part D is 1. So let's see if it lets you. No, you can only check 1. So that's strange. Because see, oops, I forgot my point though. Missed that. There is a 0.81, which is correct. So I don't care for how this is questions asked, but they're basically saying where does it start? Oh no, it did not. Which of the probability swing parts A is a valid CDF? A is, B is. Oh, A's not. It starts at 0.1. What am I doing? The only one is 0.81. Returning my question. So be careful. I was thinking A was the start. So I said it, didn't pay attention. So read carefully. The only value is the same, but 0.81 is in both of these. So the answer is the 0.81. So, but it's in B and D. Yeah, all right. I want to see if I'll take D though. No, that is weird. Because it says it's correct. Yeah, sometimes that happens with the software. Obviously, D and B are correct because they're both the same value, but it would be. So there's sometimes check my work will help make sure. And it is frustrating. I do understand that. So this is a good one for Excel. Again, it doesn't have the link, I don't think. Let me open it big. It does not. So we got to just take a second and just type all this in. So I'm going to delete everything I've done and just type it in. And for this problem, I highly encourage you to do this because it will definitely save you a lot of time. Get rid of my Word CDF. And I have videos going through this in way more detail. So watch those videos if they talk more about the concepts. This one I'm just talking about how to do some of the problems in the homework. And again, they say it sums to 1. Make it big just to verify I didn't mess up any of my numbers. And it sums to 1, so that's a good thing. All right, so find the mean. To find the mean, or type this here, mean, you take x and you multiply it by the probability of x. So and this is where Excel comes in very helpful, sorry. So click on the cells, it's that type of the numbers. And so I put in a 0, because that's the first one, and I times it by the probability. And 0 times 0.02 is 0. But now what you can do is you click on this cell. See, I have like this big plus. If I move to the bottom right, it becomes a small plus. Click and hold on your mouse and drag it down. And it just did all the calculations for you. So it multiplied every one of the x's and p of x's. And then we'll make it big so we see our sum. Highlight all the numbers and then add them together. And this gives you your mean. So to find the mean again, it's x times p of x, and then you add them together. So my mean is 1.98. All right. Now, standard deviation is a longer process, right? So to find the standard deviation, the first thing is there's a couple formulas, right? So I'm going to use what I call the regular formula. So x minus the mean squared times p of x. All right, so that's the first step. So I'm just going to put that formula into my thing. So equals parentheses x minus the mean. Now, if you want to, we don't want the mean to change when we drag this down. So we got to put dollar signs around D and 9. If you hit F4 on your keyboard, it puts them in for you, or you can just put them in. That locks that number, so it stays the same. We square it because we're adding and we don't want negative answers. And then we're going to multiply that by its probability. and then I hit enter. All right, and then I will also drag him down because now it does it all. And then by locking the mean, it never changes that value, and that is key. So now I want to add them up. So this gives me that total. All right, so after I add all those up, there's one final step, right? Because what this actually gives me is not the standard deviation. This gives me the variance. So to find the standard deviation, I take the square root of the variance. So I just type in x out equals SQRT for square root. And see, if you put my mouse over, it says returns the square root. So I double click that, click on my variance, which is what I just found, and I get the standard deviation of 1 point. So this is my variance, and this is my standard deviation. And we already know 1.98 is our mean. So 1.14, and we're good. It wants to know if our distribution is skewed. The easiest way to look at this is highlight both x and p of x together, hit insert, and put in a bar graph. No, that's not the one I want. There we go. Put a dot. My graph's way over here now. And so remember, our skewness looks like our foot. So here's our big toe. Here's our baby toe down here. So it looks like your right foot as you're looking at big toe, baby toe. No, therefore it is skewed to the right. Again, we can create our table for these. I'll open a new sheet since I have so much going on in this one. So is buying hurricane insurance for its off-coast drilling platform. The next 5 is probably a total loss of only the above water structure is 330 million. So 330 million. And I don't have to write all the zeros because the answer has the word million in it. The probability of total loss of the facility is 0.35. So that's our x. And this is our probability of x. So this is 0.35. The probability of total loss of the facility is 830 million. And that is a 0.35 as well. And the probability of no loss, so I lose no money, so that's a 0, is 0.30. Expected is the mean. So again, x times p of x. And because they want it as a possible value, I don't have to make these as negatives, right? Because it's expected loss. If I wanted to talk about profit, these would all have to become negative. Not the probabilities, the x's. So this times this, oops, this. Enter, do our little drag. And then again, add them up. So 406 million is our expected loss. So that's the power of these probability distribution functions. The number of tickets in a uniformly distributed, right? So what we need to remember here is, let me bring up my pen. Uniform distribution, the first number is what we call the letter A. The second number is what we call the number B, right? So to find the mean, the formula is A plus B over 2. So the mean formula is A plus B divided by 2. and I would put parentheses in because you must add before you divide. So 3 plus 8 is 11, divided by 2 is 11 over 2. Right, I just took those numbers and put them in. So this equals 11 over 2. And again, I'll put in a decimal here in a second. To find the standard deviation, again, I always say find the variance first. That's how I just like to do it. I always find the variance, because to find the standard deviation, I just take the square root of the variance. So the formula for variance, and I'll put it in brackets, is bracket B, oh, in parentheses. So you take B minus A plus the number 1, and we're going to square this. And then you're going to subtract 1, close the bracket, divide by 12. And then to find standard deviation, we take the square root of the variance. So just so you can see my calculations, I am going to use Excel. So, and I'm just going to type in the equation. So equals, bracket, parentheses, parentheses. B is 8, so 8 minus 3 plus 1, close parentheses, and then the little caret key to shift 6, square that, subtract 1, close with the brackets, and then divide by 12. I literally just typed in the equation into Excel so that it can see. And that's why I like to use Excel. Do you have to? No, you can do this in your calculator. I like to use Excel because I can make sure all the numbers are where they're supposed to be. And when they're not, I can hit equals. No, Excel doesn't like brackets, so we'll just put in an extra set of parentheses. So make double set of parentheses here. So Excel doesn't like the brackets. They're only brackets are groupings. It's just so they don't look, it looks neater with the brackets versus having all these parentheses, but Excel wants parentheses. So parentheses, parentheses, good. So I get 2.91. Then I take the square root because that's our variance to find our standard deviation. And I get 1.17. So our mean is 11 over 2, which is 5.5. And our standard deviation is 1.7. How many decimal places? 2. So 0.7 becomes 1. And there you go. So again, recap. Mean formula A plus B divided by 2. First number is A, second number is B. Variance is B minus A plus 1, all of that squared. Then subtract a 1, then divide everything by 12 to get your variance, and then take the square root of your variance to get your standard deviation. What is it probably? Oh, this is just how I'm gonna write these things. Okay, so at least is at least 8 is greater than, so at least means 8 or more, but it does include the number 8. Fewer than 6 does not include 6, so that is less than 6. At most 10 means 10 can't be higher than 10, so that's 10 or less. Right, so probability, the wording is tricky, so this is a good wording question. For binomial, all right, so now a binomial problem, and again, I have videos explaining these, and the lectures talk about what these are. So remember, this video is just how to do calculations. Please watch the other videos and read about what these distributions are. But binomial is a success failure type problem. And so our book likes to use, it looks like a pi symbol. If you take another statistics class, in some of my videos, I call it, it's the letter P. So just realize that this is very specific to this textbook. Other textbooks will put a P. There is always an N, but typically this is P because it is a probability, but our textbook likes to use this little pi symbol. So N equals 46. The probability of success is 60%. So to find the mean, the formula for binomial is n times its probability. And then to find the standard deviation is n, what was it, ugly n, times the probability of success times the probability of failure, which is just 1 minus the probability of success. Again, that is your variance. So what I'll end up doing is take the square root of all of that, and I will have my standard deviation. So 46 times 0.6 is the first mean, and then equals the square root of, again, 46 times 0.6, oops, not 6.60 times parentheses 1 minus, and you can simplify these steps down. I'm just showing you all the steps so you can see it, right? Because it's n, 46, probability of success, 60% or 0.6. Probability of failure would be 40% in this case, which is just a complement of 1 minus 0.6. So we have 27.6, and we have a standard deviation of 3.2 decimal places, so 3.2. Check my work. Oh, it does not like that answer. Why not? Oh, right, round, again, return my question, read carefully. Mean is 2 decimal places. Standard deviation, because I have this shrunk down, is 4 decimal places. So 3.265, so that's 3.27. There we go. So read carefully, 2 and 4. All right, so I'll let you finish the rest of those. Remember, mean, n times the probability. Standard deviation, n times probability of success times probability of failure, and take the square root. All right, so for this problem, a noodle company restaurant, the probability a customer will order a non-alcoholic is 55% or 0.55. Find the probability they sample 14 customers. None of the 14 will order a alcoholic drink. So it doesn't state it in here, but this is a binomial problem, right? Because we have, you either order a drink, non-alcoholic drink, or you do not order one. We're going to assume that they're independent and the probability does not change, because those are 2 of the rules for probability. And we need a sample size, which you can see for all of our problems is 14. So this is a binomial, right? And so in Excel, there is a function called binomial dist. So equals binomial dist. So binomial.dist. And this will help us find these probabilities. So for in Excel, what we need number of success, we need the trials, which is n, and the probability of success, right? So our probability of success is 0.55, so that does not change. Our trials is 14. And so now what we have to do is figure out what these things are. So I'll come back to this in a minute. So for part A, right, find the problem that a sample 14 customers, none of the 14 will order. So that means in this one, we get x equals 0. No one orders a drink. So then I can do binomial dist. My number of success is 0 because no one ordered a drink. My trials is 14 people. The probability of getting them is 0.55. And cumulative means, do you have a less than and equal to, or do you have an equal to? Our problem is we have x equals 0, so that is an equal to. So I pick false or put in a 0. And this wants 4 decimal places. And you put mine in scientific notation. So this is going to be means that they got to move the decimal to the left because it's a -5. 4 places, right? So this becomes, oops, escape. 0 point. We got to put in 4 zeros, and then it's 139,629. So that's how I took that number and then put it into decimal form. But basically my answer is going to be 0.00 because 4 decimal places, 0, 1. All right, so for part B, find the probability at least 3 will order. So remember, at least from the previous problem we did, that is greater than, so this is greater than or equal to 3. That's what at least means, right? But Excel doesn't want that. Excel wants equals or less than. So another way to solve this is if I find the complement. So the complement would be X is less than 3, or for Excel purposes, for CDF purposes, it's X is less than or equal to 2, because we're discrete. You can't have part of a person, so I come down a whole number, right? And so now what I can do is, now that I have this, I can solve this. So this is equals binomial dot dist. Again, now my number of success is 2. My trials is 14. My probability of success is 0.55. And now, because it is less than or equal to, I put in, oops, comma, 1 or true. I'm just going to put a 1. You can see it highlights the true. And so there's the probability of being 2 or fewer. However, I want 3 or more, or at least 3. So I'll come back up here in my Excel, and to do that, I just take the complement of the previous answer. So 1 minus its complement, and I get point. I'll return to my question. 0.99785. 4 decimal places, so 1, 2, 3, 4. So that 8 becomes a 9. So last two, I'll just work with the fewer than 4. So C, I'll let you work through these. Fewer than 4 would be X is less than 4, or X is less than or equal to 3. So now it is in the right format, so you can put that one in. Find probably the sample all. So this one is X. So D would be X equals 14. All right, so make sure you do like question 6 and put them in the right format. So to use Excel, it either has to be an equals problem or it has to be less than or equals problem. If it's an equals problem, you put in a false at the end. If it is less than or equal to, you put a true in at the end, right? So remember those are key for doing this problem. And then the last problem is another expected value problem. So create your probability distribution function, and then you can figure out your winnings. As always, please reach out to me if you have any questions about this video or anything in the class. I hope everybody has a good week.